Okay, here is the video for anyone who still did not get the idea of determining the number of real and non-real solutions for a quadratic equation using the discriminant. A very important point we need to know, we do not focus on the whole quadratic formula. We're not taking all of this. We focus only on the part of the formula that has to do with either real or non-real solutions. And that's definitely what's in the radicand. Okay, so we focus only on this v squared minus 4ac. So to find it, normal way, it's just I will determine a equals 3, b equals -6, c equals 2. I'm not going to substitute into the whole formula. I will take only this b squared minus 4ac. Let's use a letter d, the letter d, to represent it. It equals b squared minus 4ac. So this d, it's what's in the radicand. It's what we want to find the square root of. Then let's try to replace or substitute the values. B squared is going to be -6, 4 squared minus 4. A is 3 and C is 2. It's going to be 36 minus 4 times 3, 12. 12 times 2 is 24. So the discriminant will equal 12. The value that I need to find the square root of, it's positive. It's positive. So we have three cases. The first one, when the discriminant positive, that is greater than 0. When the discriminant is negative, that's less than 0. When the discriminant is equal to 0. In each case, we have an answer. In each case tells us how many real or non-real solutions we have. Definitely when the discriminant is more than 0, I can find the square root of a positive number because it's a real number. So this will have 2 real solutions. And when d is less than 0, a square root of a negative number is non-real. So this will have 2 non-real solutions. This is clear? Yeah. I think it looks like n. Anyway, yes, yes. And when the discriminant is 0, the square root of 0 is equal to 0 in all cases. So the second term, the second part of the formula will make no change. I plus or minus 0, so I make no difference. I will have only one real solution, that is negative b over 2a. I can say that it's one real solution. Back to my question here. The discriminant is equal to 12, which is definitely greater than 0. So this quadratic equation has how many? 2 real solutions. I guess that's clear, isn't it? Let's come to the next one. Again and again, we're not focusing on the whole formula. We're taking only this part, the discriminant. Yes, let me change the color. Yeah. Okay, here it is. A equals 2, B equals -3, and C equals 2. The discriminant equals B squared minus 4AC, which is equal, direct substitution, -3 squared minus 4. A equals to 2, and C equals to 2, which is 9 minus 4 times 2 is 8 times 2, 16. Then the discriminant is equal to -7. In this case, the discriminant is less than 0. It's less than 0. So this quadratic equation has 2 non-real solutions. Let's come to our last example. Again, I'm focusing only on the discriminant, the value that's in the radicand. Let's identify A, 5 is equal to 5, and then B is equal to -20, and then C is equal to 20. The discriminant will equal B squared minus 4AC as so direct substitution, negative 20 squared minus 4 times 5 times 20. Negative 20 squared is 400. And 4 times 5 is what? Is 20, and 20 times 20 is 400. So the discriminant is equal to 0. And as long as it's equal to 0, that means what? This quadratic equation has how many solutions? It's only one real solution. I guess it's clear. So you know your A, your B, your C, and then substitute them into the discriminant and see if the discriminant is equal to 0, less than 0, or greater than 0, based on which you determine the number of real and non-real solutions.